on specifically on transfer learning for deep learning. These are the main topics which will be covered in this unit. Like first, I shall introduce what is transfer learning, why is it required, what are the applications, and so on. Then we shall discuss data augmentation, different techniques to augment data. Pre-trained CNN models will be discussed. And there are several pre-trained CNN models, but they all will not be discussed. Among all those pre-trained CNN models, some of them are very popular and they have been proved very beneficial for several real-life applications. So they are included in your syllabus, so they will be discussed. And finally, a brief discussion on regularization, dropout, and batch normalization. In fact, dropout and batch normalization, they were already discussed in previous units. So I may, skip these topics. I'll first check that what was exactly covered in previous units, and accordingly, I may skip this topics. Okay, so let me first introduce this transfer learning. Okay, now as we know, we humans are very perfect at applying the transfer of knowledge between different jobs, between different tasks. What does I mean? I mean that whenever we encounter a new problem or a new task, we recognize it and apply our relevant knowledge from our previous learning experiences. So what's the advantage of this? Like this makes our work easy, our new task easy, and we be able to finish our new task in short time. So the more related the task, the easier it is for us to transfer our knowledge, or easier it is for us to cross utilize our knowledge. I give you simple examples for this. Suppose you know how to ride motorbike. Okay, so when you know how to ride a motorbike, you can learn how to ride a car, because like you are not riding a vehicle for the first time. So as you know how to ride a motorbike, you can quickly learn how to ride a car. Suppose you know how to play classic piano, then you can learn how to play jazz piano. Some more examples like math and statistics. So you can learn machine learning easily, because we know that machine learning and data science, they include statistics. So we usually transfer our relevant knowledge for our new jobs, for our new experiences. Okay. So in each of the examples which I just discussed, we don't learn everything from scratch. When you want to learn machine learning, when the concepts of statistics are taught to you as a part of machine learning syllabus, you simply recall them because you have learned those concepts during your school time. So we you don't learn everything from scratch when you attempt to learn new aspects or topics, right? So what we do, we transfer and leverage our knowledge from what we have learned in the past. I hope this is clear. So, for example, if you know how to ride a bicycle and if you are asked to ride a motorbike, which you have never done before, in such case, our experience with the bicycle will come into play and handle tasks like balancing the bike, steering, etc. Like some new learning gets added, and this will make things easier compared to a complete beginner. So such learnings are very useful in real life, as it makes us more perfect and allows us to on more experience. And following this approach, a term transfer learning was introduced in the field of machine learning. And this approach involves the use of knowledge that was learned in some task and applying it to solve the problem in the relevant target task. Okay. So conventional machine learning and deep learning algorithms, which we discussed so far, they have been traditionally designed to work in isolation. But this transfer learning okay, this conventional algorithms are trained to solve specific tasks. They have been designed to work in isolation, and they have been trained to solve specific tasks. The models have to be rebuilt from scratch once the feature space distribution changes. So, transfer learning is the idea of overcoming the isolated learning paradigm and utilizing knowledge which is acquired uh, for one task to solve related one. So, transfer learning, in short, we can say that from the the points we discussed just now, we can say that transfer learning is the reuse of trained model on a new problem. It is the reuse of a pre-trained model on a new problem. It is currently very popular in deep learning because it can train deep neural networks with comparatively little data. Because otherwise, to train deep learning models, you need a huge amount of data. But due to this transfer learning, we can train this deep neural networks with comparatively small amount of data, and by harnessing the ability to reuse existing models and the knowledge of new problems, this transfer learning has opened doors to train deep neural networks even with limited data. So this is a primary advantage of using the concept of transfer learning in deep learning, that we can train deep learning models with small amount of data. And this is very useful in data science. And because this is very useful in data science, because most real world problems, if you remember when we were discussing healthcare use cases, I discussed with you the amount of data we used to train our model. So, and that's why like we also used pre-trained CNN, because in most real world problems, typically we do not have millions of label data points to train complex deep learning models. And so we prefer to use this transfer learning. Okay. Now, let us understand what exactly the transfer learning is. And as you can see, this figure shows the difference between traditional ML and transfer learning concept. Just we discussed that traditional machine learning is isolated single task learning. Okay, so here you can see that data set 1, learning system task 1, data set 2, learning system task 2, and so on. So knowledge is not retained here. Please understand this. The knowledge gained by machine learning model or deep learning model, it is not retained or it is not accumulated. So learning is performed without considering past learned knowledge in other tasks. So that is traditional machine learning. But what is transfer learning? Learning of a new task relies on the previous learned task. So learning process can be faster because a model has some knowledge, relevant knowledge, and more accurate, and or you can say it will need less training data. So here you can see how this scenario looks like. Data set 1, learning system task 1, it retains this knowledge. This knowledge is transferred when it has to learn some other task. So at that time also data set 2 is also used. I'll explain you what's the purpose of this. Of course, this is required because this is a new problem, new task. So data set will be there, but this may be a data set having a small amount of data. You can see that this is a small circle compared to the rest of the circles. So even if you have a small amount of data, you can solve your problem. So that is the advantage here when we use transfer learning. Okay. So what is as we have discussed, knowledge of an already trained machine learning model is applied to different but related problem. The retained knowledge, the gained knowledge is applied to different problem, but the problem is relevant. For example, if you trained a simple classifier to predict whether an image contains a backpack, you could use the knowledge that the model gained during its training to recognize other objects like sunglasses. Right? So with transfer learning, we basically try to exploit what have been learned in one task to improve generalization in another. So we transfer the weights. Okay, so what we transfer here? When we say that the learning is transferred, the knowledge is transferred. So what exactly is transferred? That we transfer the weights that a network has learned at task A for a new task B. What we transfer? We transfer the weights that a neural network has learned for task A to for a new task B. So the general idea is to use the knowledge a model has learned from a task with a lot of available later label training data in a new task. Okay, so transfer learning is mostly used in computer vision and natural language processing tasks. Please understand this. Where we use transfer learning, I'll also show you some models that which are the models which have been designed for natural language processing and which are the pre-trained models available for computer vision. So this transfer learning, which are the application areas? Computer vision and natural language processing. Now, computer vision includes object detection, object classification. So where we there we use this transfer learning. Okay. So this in natural language processing tasks like for sentiment analysis, we use pre-trained model because we don't have the huge amount of computational, because when every time for a new task, if we have to train from scratch, even if we have a large amount of data, it requires more computational power. So that is also advantage here, that it reduces the computational power. Okay, here I would like to make one point. I would like to clear it that transfer learning is not really a machine learning technique. See here, this figure shows transfer learning versus machine learning, right? So transfer learning is not really a machine learning technique, but can be seen as a design methodology within the field. For example, active learning. It is also not an exclusive part or study area of machine learning, right? So they are different. Okay, how this transfer learning works? Okay, so before we move to the next slide, let me tell you how transfer learning works. If I tell you briefly, let's go back to the example of model trained for recognizing that backpack on an image, which will be used to identify sunglasses. How it is used, for in computer vision, neural networks usually try to detect. Okay, please understand this clearly. For computer vision applications, the neural network usually try to detect edges in the using the earlier layers, shapes in the middle layer, because all the objects, they have different features like edges, shape, texture, color, etc. Right? So these are the different features of objects. So neural networks, they learn edges using earlier layers, shapes using middle layer, and some task specific features in later layers. Okay, so in transfer learning, the early and middle layers are used, and we only retain the late we only retain later layers. Okay, it helps leverage the label data of the task it was initially trained on. Fine. So if we go to that example of backpack and sunglasses, in earlier layers, the model has learned to recognize object. Because of that, we will only retain the later layer. So it will learn what separates sunglasses from other objects in later layers. Later layers will be useful to separate sunglasses from other objects. So in transfer learning, we try to transfer as much knowledge as possible from the previous task. The model was trained on the new task. Okay. Okay. Now let us move to the next slide, and I would like to discuss why this is required, why transfer learning is required. Okay. What's the necessity of this transfer learning? So the necessity is that please understand this. Many deep neural networks trained on images have a curious phenomenon in common. In early layers of the network, a deep learning model, as just we have discussed, tries to learn a low level of features like detecting ages, colors, variation of intensity, etc. These are called low level features. Now, such kind of features appears not to be specific to a particular data set. Ages detect करने हैं, तो उसमें कोई data set के साथ particular data set के साथ ज्यादा relation नहीं है. Colors, the types of colors, variety of colors, they are same, irrespective of whether data set contains images of flowers, images of animals, space related images, because these are colors. Okay, colors are known and they are like common colors. It is not, colors do not represent task specific features. So these are called, these are called low level features. And such kind of features appears not to be specific to a particular data set or a task, because no matter what type of image we are processing, either for detecting vehicles or detecting an animal. In both cases, we have to detect this low level features. अगर हमें vehicle को classify करना है या फिर हमें एनिमल्स को क्लासिफाई करना है, हमें दोनों में ये फीचर्स, ये लो लेवल फीचर्स जो है, वी नीड टू डिटेक्ट. So earlier layers are used to detect this low level features. Now all these features occur regardless of the exact cost function or image data set. And thus learning these features in one task of detecting lions can be used in other tasks like detecting humans. Okay, so this way the transfer learning. So necessity is that low level features learned for task A, as you can see in this figure, should be beneficial for learning of model for task B. So this is what transfer learning is. Nowadays, it is very hard to see people training whole convolutional neural network from scratch. Please remember, like you will hardly see that researchers are training these convolutional neural networks from scratch. And it is common to use a pre-trained model trained on a variety of images in a similar task. For example, model trained on ImageNet. Now, what is ImageNet? It is a ImageNet like data set. It includes 1.2 million images with uh, several objects. So the block diagram shows that pre-trained model is trained for task A, the knowledge is retained, and for task B, a new model is created using the knowledge. Fine. Okay. Now, okay, when dealing with transfer learning, we come across a phenomenon called the freezing of layers. This is like something new I'm telling you now, that when you are dealing with transfer learning, you have to freeze some layers. A layer, it can be a CNN layer, it can be a hidden layer or a block of layers or any subset of set of all layers. So is said to be fixed when it is no longer available to train. जिस लेयर्स को आप ट्रेन नहीं कर रहे हो, उस लेयर्स को आपको फ्रीज करने पड़ते हैं. राइट, वंस यू हैव ट्रेन मॉडल फॉर टास्क ए. अच्छा, आपने टास्क ए के लिए मॉडल को ट्रेन कर लिया. नाउ व्हेन यू आर सॉल्विंग टास्क, व्हेन यू आर वर्किंग फॉर टास्क बी, व्हाट यू विल डू, यू विल फ्रीज सम ऑफ द लेयर्स of model for task B. The weights of freeze layers will not be updated during training. आपने freeze कर दिया, मतलब क्या हुआ? Please be with me and visualize the architecture of convolutional neural network. Remember that I told you that convolutional neural network. Please remember that I told you that the different blocks are used, different blocks of convolutional layer and that pooling layer, right? So multiple such layers are used in convolutional layer. And when you are using convolutional neural network, let's say for task B, then what you will do, you will freeze some of these layers. सो फ्रीज मतलब क्या, उनके वेट्स आप चेंज नहीं करोगे। जब आप ट्रेन कर रहे हो आपके नए टास्क के लिए, नए डेटा सेट से ट्रेन कर रहे हो, तो यू विल नॉट चेंज द वेट्स ऑफ दोस फ्रीज्ड लेयर्स। Hence, like you will not, and while layers that are okay, so you will freeze some of the layers and some of the layers are unfrozen. So the layers that are not frozen follows regular training procedure जो हम already करते हैं training में कि weights update करना, bias update करना and so on. So when we use transfer learning in solving a problem, we select a pre-trained model as our base model because there are so many pre-trained models. So we use one of them as base model. And now there are two possible approaches for knowledge transfer. The first way is to freeze a new, a first way is to freeze a few layers of the pre-trained model and train other layers on our new data set for the new task. That is the first approach. Second is to make a new model. Please understand, मैंने कौन सा फर्स्ट में बताया? यूज प्री ट्रेन मॉडल, जैसे मैंने बताया एलेक्स नेट, गूगल नेट, रेज नेट, दिस आर द प्री ट्रेन मॉडल्स. So use them. Okay, now if you're using them, then freeze a few layers of the pre-trained model and train the rest of the layers on a new data set. This is one approach. Okay. Second approach is to make a new model. पूरा नया मॉडल ही बनाओ, pre-trained मॉडल नहीं लेना है, but also take out some features from the layers in the pre-trained model and use them in a newly created model. So in both cases, we take out some of the learned features and try to train the rest of the model. This makes sure that only feature that may be the same in both of the tasks is taken out from the pre-trained model and the rest of the model is changed to fit the new data set by training. So here you can see how it looks like when we freeze some of the layers. I told you that earlier layers are used to extract the low level features और वो usually same रहते हैं, like colors, intensity of colors, ages. तो हम earlier layers को freeze कर सकते हैं, and जो पीछे की layers है which extract the high level features. High level features are the features related to specific task. So we can train only those layers in multiple epochs, in multiple iterations, right? Okay. Any question till this point? Any question? I hope you are understanding and you are with me. Are you with me? You can write your answer in chat box. Let me check you are with me or not. Okay. 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 So 4 of you are with me. Fine. I don't know about rest of you. Please be with me. This is very important concept. Third unit onwards, like you are learning the core of the subject, right? CNN architecture, then transfer learning and pre-trained CNN models. Fine. So if no question till this point, then we can move ahead. Okay. So, okay, we discussed that later layers are used to extract the high level features. Okay, now if there is a pre-trained model which detects humans in images and we want to use that knowledge to detect cars, in such case where the data set is entirely different, because पहले हमने मॉडल को ट्रेन किया vehicle classification के लिए, and now I want to use the knowledge of this model for human classification. Okay, so not matlab in such case where the data set is entirely different, it is not good to freeze lots of layers, because there is always a question na ki how many layers should be freezed. One may ask how to determine which layers we need to freeze and which layers need to train. अभी तो मैंने सिंपल एक ये फिगर में दिखा दिया कि आगे के लेयर्स फ्रीज कर दो, पीछे के लेयर्स ट्रेन करो. लेकिन how to select? So the answer is simple. The more you want to inherit features, listen carefully. The more you want to inherit features from a pre-trained model, the more you have to freeze the layers. अगर आप ज्यादा नॉलेज यूज करना चाहते हो प्री ट्रेन मॉडल का, तो freeze more layers. For example, if the pre-trained model detects some flower species and we need to detect some new species, then in such case, a new data set with new species contains a lot of features similar to trained model. Thus, we freeze less number of layers in this case, right? But if there is a pre-trained model which detects humans in images and we want to use that knowledge to detect cars, so in this case, it is not good to freeze lots of layers, because freezing a large number of layers will not only give low level features, but also give high level of features like nose, eyes, जिसकी जरूरत ही नहीं है जब आप vehicle classification कर रहे हो. जब आप ह्यूमन क्लासिफिकेशन करते हो तो ये सारे फीचर्स उसको लर्न करने हैं, नोज, आईज एक्सेट्रा. अगर हम ज्यादा नॉलेज ट्रांसफर करेंगे तो ये सारा नॉलेज, ये हाई लेवल फीचर्स भी ट्रांसफर होंगे. And this high level features are not required when we are classifying this vehicles. Okay, so like it depends that what kind of problem, what kind of knowledge you are it depends on new problem, that which kind of knowledge should be transferred, and accordingly which layers should be freezed. Okay, so we can say that we only copy low-level features from the base network and train the entire network on a new data set. So actually, there arise four scenarios here. I show you that which are the four scenarios. See, these are the four scenarios here. Okay, so these are the four possible situations where the size and data set of the target task, new task, vary from the base network, that is pre-trained network. So the first scenario is the target data set is small. Target data set is small and similar to the target data set. Target data set means new data set for new task. So this new data set is small. Okay, and it is similar to the base network data set. Base network data set means pre-trained मॉडल का जो डेटा सेट था उससे न्यू डेटा सेट सिमिलर है. न्यू डेटा सेट इज स्मॉल एंड सिमिलर टू द डेटा सेट यूज्ड टू ट्रेन pre-trained model. Now here the target data set is small. That means we can fine tune the pre-trained network with the target data set, but this may lead to the problem of overfitting. So there may be some changes in the number of classes in the target task. So in such case, we remove the fully connected layers from the end and maybe one or two, and add a new fully connected layers satisfying the number of new classes. So now we freeze the rest of the model and only train newly added layers. Okay. The second scenario is the target data set is large and similar to the base training data set. So in first two scenarios, the target data set differs, either small, large, and the pre-trained model use the similar kind of data set. Okay, so features will be, most of the features may be same because the data set was similar. So in such case, in second scenario, when the data set is large and it can hold a pre-trained model, there will be no chance of overfitting because a new data set is sufficiently large. And hence the last fully connected layer is removed. Okay, only last fully connected layer is not one, like more than that. And a new fully connected layer is added with the proper number of classes. And now the entire model is trained on a new data set. This makes sure to tune the model on a new large data set, keeping the model architecture the same. Okay, I hope you are with me. The third possibility, where now the third, like again, now we will have target data set small and large, but the difference is the data set which was used to train pre-trained model was different. Like it was not similar to this data set. So in this case, what is possible? Now, since the target data set is different, दोनों के डेटा सेट्स बहुत डिफर कर रहे हैं. यूजिंग हाई लेवल फीचर्स, डेटा सेट डिफर करना मतलब मैं आपको बताती हूँ. जैसे अभी हमने एग्जांपल्स डिस्कस किए कि यू हैव लर्न हाउ टू राइड बाइसिकल एंड देन यू कैन इजीली लर्न हाउ टू राइड मोटरसाइकिल. इफ you know how to ride motorcycle, you can easily learn how to ride how to drive car. तो ये सिमिलर नॉलेज हुआ ना, सिमिलर टास्क हुआ, सिमिलर नॉलेज आपको चाहिए उसमें, तो थोड़ा आप ट्रांसफर अच्छे से कर सकते हो. लेकिन आपने कार राइड करना है एंड न्यू टास्क इज लाइक, जैसे हमने वो एग्जांपल्स डिस्कस किए. फॉर एग्जांपल, न्यू टास्क इज क्वाइट डिफरेंट. मतलब आपको यहाँ पे राइड नहीं करना है, बट लेट्स से द एग्जांपल व्हिच वी वर डिस्कस्ड वेयर, सपोज यू वांट टू प्ले पियानो और यू वांट टू ड्रॉ, सपोज कुछ ड्राइंग बनाना है आपको. सो उसमें आपको ये मोटर बाइक राइड करने वाला नॉलेज काम नहीं आता है, राइट? बिकॉज यू वांट टू प्ले पियानो, इट रिक्वायर्स, सो डेटा सेट इज डिफरेंट, डिफरेंट नॉलेज इज रिक्वायर्ड हियर. Because you learned how to ride motorbike and now you want to learn how to play piano. So these are not similar problems, right? You know mathematics. So the knowledge of mathematics is not useful to ride a motorbike, because these are different tasks. So this way it depends, like scenarios are different. 4 scenarios are possible here. And the third scenario is, as we can see, third scenario is target data set is small and different from base network data set. So since target data set is different, using high level features of the pre-trained model would not be useful here. And in such case, जहां पे डेटा सेट सिमिलर है तो हाई लेवल फीचर्स भी यूज कर सकते हैं, एंड हमें सिर्फ और सिर्फ वो क्लासिफिकेशन वाला जो लेयर है, फुल्ली कनेक्टेड लेयर, उसे ही हमें रिप्लेस करने की जरूरत है. बट जब ये डेटाबेस डिफरेंट है तो वी कैन फ्रीज ओनली सम अर्लियर लेयर्स and we cannot use high level features of the trained model. In such case, remove most of the layers from the end in a pre-trained model and add new layers. This way we can use low level features from the pre-trained model and train the rest of the layers to fit a new data set, to learn high level features from the data set. And sometimes it is beneficial to train the entire network after adding a new layer at the end. And the fourth scenario is a target data set is large and different from the base network. So since the target network is large, target data set is large and different, the best way is to remove the last layers from the pre-trained network and add layers with a satisfying number of classes. So these 4 possibilities are there. Okay. So in summary, I may say you that the 3 important questions need to be answered when you are I mean 3 important questions need to be answered during the process of transfer learning, and these 3 questions are: what to transfer, when to transfer, and how to transfer. What to transfer, when to transfer, and how to transfer. These 3 questions need to be answered. I repeat, what to transfer means this is the first and the most important step in the whole process. We try to seek answer about which part of the knowledge can be transferred, matlab low level features only, या फिर low level and high level features also. So this is very important question. Second is when to transfer. There can be scenarios where transferring knowledge for the sake of it may make matters worse than improving anything. So this is also known as negative transfer. Negative transfer. So we, like, when to transfer is very important. We should aim at utilizing transferring knowledge to improve target tasks, results, right? So we need to be careful about when to transfer and when not to transfer. And the third question is how to transfer. Once what to transfer and when to transfer have been answered, we can proceed towards identifying ways of actually transferring across domains and tasks. So this involves changes to existing algorithms and different techniques. Fine. So that is about the necessity of transfer learning. Okay. Any question till this point? So we discussed this necessity of transfer learning. and only two major topics. And sorry, uh, oh, I'm, it's slow at my end. Okay. Yeah, I don't know why it's happening like this. Okay. Anyway, oh, diagram is not visible because can you see diagram? No, na. I think I lost connection in between.
No, ma'am, diagram is not visible.
Not visible, na. Let me present again. Yeah, yeah. Let me present again. Think it's visible now.
Yes, ma'am, visible.
Yeah. So these are the transfer strategies. We have seen what is the necessity of transfer learning, and we learned the difference between traditional ML and transfer learning and necessity for transfer learning. Now let's see the various transfer learning strategies. So here you can see that mainly there are three types of strategies: inductive transfer learning, transductive transfer learning, and unsupervised transfer learning. These are the three major categories of transfer learning, okay, which can be applied based on the domain, task at hand or problem at hand, and the availability of data. Of course, we know that if it is unlabeled data, then unsupervised transfer learning will be used, right? So this strategy can be applied based on the domain of the problem, task at hand, and the availability of data. Okay, okay. I tell you now here, based on the like transfer learning methods, as we have seen that they can be categorized in these three categories. Now, what is inductive transfer learning? In inductive transfer learning, the source and target domains are the same. Source and the target domain are the same, yet the source and target task are different from each other. Okay, I repeat this and I'll tell you. Okay, domain is same, but the task is different. For example, uh, depending like here the algorithms try to utilize the inductive biases of the source domain to help improve the target task, and depending upon the whether the source domain contains label data or not, this can be further divided into two subcategories similar to multitask learning and self-taught learning, like respectively. So domain means domain like if it is agriculture domain, okay, if it is healthcare domain. So domain is same, but in healthcare domain, suppose uh, I may be identifying corona disease from the CT scan of chest, and the new task may be identification of TB disease from the chest X-ray, because sorry, not CT scan. It may be one kind of modality, because from X-ray image also some diseases can be identified from CT scan, like it is a higher level diagnostic test. If disease is not easily identified from X-ray, so here, like suppose you have trained your model to identify pneumonia disease from chest X-ray, and now you are using this knowledge of this model to identify TB from the chest X-ray only, right? Or CT scan. Instead of X-ray, you can consider CT scan. So see, the organ is same, domain is same, the type of modality is same, right? You are collecting here, you are considering the same chest X-ray. But earlier you considered chest X-ray for pneumonia disease diagnosis, and now you are considering it for corona or TB diagnosis. So here the domain is same, okay? But source and target, just a second. Okay. So here you are using the knowledge gained from the previous domain is same, only the task is different, right? So this is like inductive transfer learning. Unsupervised transfer learning, this setting is similar to inductive transfer learning itself with a focus on unsupervised tasks in the target domain. The source and target domains are similar, but the tasks are different. So in this scenario, labeled data is unavailable in either of the domains, either like previous or this one, right? Okay. Now the third one is uh, transductive transfer learning. In this scenario, there are similarities between the source and target tasks, but the corresponding domains are different. Now see this. Source and target tasks are similar. Classification of, let's say, classification of disease, classification of disease from some medical image modality, and the classification of uh, plant disease, right? The target is disease classification, but the corresponding domains are different. Like in first case, the domain is you want to identify human disease, and in second case, plant disease in agriculture. So tasks are similar, disease diagnosis, but the corresponding domains are different. So in this setting, the source domain has a lot of label data, while the target domain, I don't know, target domain may or may not. So this can be further classified into subcategories referring to settings where either the feature spaces are different or the marginal probabilities are different. Okay. So these are the different types of transfer learning strategies. I think this much is sufficient for you in because you are in BTech course. Otherwise, we can go in deep for this inductive transfer learning, transductive transfer learning, and unsupervised transfer learning. But I shall not go in deep. I think this is sufficient for this because I'm still discussing the first topic of this unit. I'll finish only one topic of this unit. I'm just introducing transfer learning, right? Okay, so what are the advantages of transfer learning? Very clear, these are the primary advantages of transfer learning, and that's why today most of the researchers they use transfer learning when they are solving the real life sector problems. Speed up the training process, it speeds up the training process. So by using a pre-trained model, the model can learn more quickly and effectively on the second task, as it already has a good understanding of the features and pattern in the data. Second, better performance, क्योंकि आपका नॉलेज बढ़ रहा है जब आप एग्जिस्टिंग नॉलेज यूज कर रहे हो और उसमें एड ऑन कर रहे हो न्यू डेटा सेट से, तो नॉलेज इज इंक्रीज. ट्रांसफर लर्निंग कैन लीड टू बेटर परफॉर्मेंस ऑन द सेकंड टास्क एज द मॉडल कैन लिवरेज द नॉलेज इट हैज गेन फ्रॉम द फर्स्ट टास्क. अगर you have not learned how to ride bicycle, you have not learned how to ride bike, right? And then directly, suppose you have learned how to ride bicycle, then you have learned how to ride uh, uh, say Access or Activa, which is without gear. And then you are learning how to ride motorbike. So you can learn because you know how to balance it and everything. Just you have to you have to add knowledge related to gear, right? So this way, as this increases the performance, agar aapne wo learn kiya hi nahi hai, if you have not tried Access, Activa, bicycle, and directly you are learning how to ride bike, then it takes long time. Training would be slow. तो यहाँ पे faster training नहीं हो सकती है, right? And performance भी धीरे धीरे improve होगा आपका. So this is the advantage. Handling small data sets when there is a limited data available for the second task. Transfer learning can help, and that's what we have done in our healthcare problems. Right? If you remember, we used how many TBUT frames in our dry eye disease detection? 300. In fact, lesser than that. And in hypothyroidism detection, we use 300 images, 150 of healthy infants and 150 of infants suffered from hypothyroidism. And in our femur fracture detection, femur fracture related problem, we got only 66 images because it was because it is our first attempt. So even if you have a small data set, when there is a limited data available for the second task, transfer learning can help to prevent overfitting, as the model will have already learned general features that are likely to be useful in the second task. Okay, so these are the main advantages. Okay, the disadvantages of this. Disadvantages are डोमेन मिसमैच. अगर डोमेन मिसमैच कर रहा है तो नॉलेज ट्रांसफर करना ज्यादा यूजफुल नहीं है. अगर हेल्थ केयर डोमेन का नॉलेज गेन किया है एंड इफ यू आर यूजिंग इट फॉर agriculture domain or education domain problem, or to solve the problem in finance sector, it won't be much useful, right? So the pre-trained model may not be well suited to the second task if the two tasks are vastly different, or the data distribution between the two tasks is very different. Okay. Second disadvantage is overfitting. Transfer learning can lead to overfitting if the model is fine-tuned too much on the second task, because it may learn task-specific features that do not generalize well to new data. And the next disadvantage is complexity. The pre-trained model and the fine-tuning process can be computationally expensive, and this is true. The pre-trained model and the fine-tuning process, because you have to you have to fine-tune the pre-trained model. Training time would be less, but for fine-tuning may take some more time, and it may be computationally expensive and may require specialized hardware. Right? So these are the disadvantages of transfer learning. Okay. Okay, now in introduction part of this transfer learning, this is the last topic that I hope by now you have learned what is transfer learning, when to transfer it, what to transfer, and how to transfer and all. Okay, so approaches to transfer learning are training a model, to reuse it using a pre-trained model, and feature extraction. So imagine, let us discuss training a model to reuse it. Imagine you want to solve task A, but don't have enough data to train a deep neural network. So one way around this is to find a related task B with an abundance of data. ये आप कर सकते हो. ओके, आप ट्रेन करो मॉडल को, एंड मान लो आप एक टास्क सॉल्व करना चाहते हो, राइट? सपोज टुडे यू हैव चोजन अ प्रॉब्लम, and but you have realized that you have a very small amount of data. So what you can do, you can find a related task B with an abundance of data, train your deep neural network, because you are training from scratch. आप कोई pre-trained model use नहीं करना चाहते हो. You have designed the architecture, और आप अपना खुद ही सॉल्व करना चाहते हो आपके खुद के मशीन से, सॉरी खुद के डीप न्यूरल नेटवर्क से, and you want to train it from scratch. So what you can do, you can find a related task B with an huge amount of data, train the deep neural network on task B, use the model as a starting point for solving task A. Now, whether you will need to use the whole model or only a few layers depends heavily on the problem you are trying to solve. So there is no standard answer for this, right? कि कितने layer freeze करने चाहिए, कितना knowledge use करना चाहिए. You have to experiment exhaustively. So if you have the same input in both tasks, possibly reusing the model and making predictions for your new input is an option. Alternatively, changing and retaining different task-specific layers and output layer is a method to explore. So this is about training a model and to reuse it. You train the model from scratch. Okay. Second way, using a pre-trained model. आप खुद मॉडल मत बनाओ, ऑलरेडी pre-trained models available है, आप उसे यूज कर सकते हो. So the second approach is to use an already pre-trained model. And there are a lot of these models available. So make sure to do a little research that which is more suitable for your problem, because बहुत सारे हैं. So you can't choose any randomly. You have to study them deeply. You have to justify that why you have chosen so and so model for your task, right? With logical reasons, you have to justify. So how many layers to reuse and how many to retain depends on the problem. Again, here there is no standard answer that when you are using pre-trained model, how many layers to reuse and how many to retain. Okay, so Keras Python library, for example, provides numerous pre-trained models that can be used for transfer learning, prediction, feature extraction, and fine-tuning. So you can find these models and also some brief tutorials on how to use them on internet. And there are also many research institutions that release trained models. Okay, so this type of transfer learning is most commonly used throughout the deep learning, this pre-trained. स्क्रैच मॉडल बनाओ स्क्रैच से सिमिलर प्रॉब्लम फाइंड करो डेटा सेट फाइंड करो ट्रेन करो उससे ज्यादा ये ज्यादा प्रिफरेबल है प्री ट्रेन मॉडल यूज करना एंड द थर्ड अप्रोच इज फीचर एक्सट्रैक्शन this is to use deep learning to discover the best representation of your problem, which means finding the most important features. This approach is also known as representation learning. ये बहुत ही recent approach है. Representation learning and can often result in a much better performance than can be obtained with hand designed representation. So, as we know, in machine learning, features are usually manually handcrafted by researchers and domain experts. And fortunately, deep learning can extract features automatically. So, of course, this does not mean feature engineering and domain knowledge is not important when we are solving problems using deep learning. You still have to decide which features you put into your network. And that said, neural networks have the ability to learn which features are really important and which ones are not. So, a representation learning, this third learning, feature learning, representation learning algorithm can discover a good combination of features within a very short time frame, even for complex tasks, which would otherwise require a lot of human effort. So, learned representation can then be used for other problems as well, and simply use the first layers to spot the right representation of features, but don't use the output of the network because it is too task specific. Okay, so this approach is mostly used in computer vision because it can reduce the size of your data set, which decreases computation time and makes it more suitable for traditional algorithms. So this third approach is more suitable for computer vision applications. Okay, so this is introduction to transfer learning. If you have any question, I would like to answer it. Any question? So I simply, what have we covered today? Transfer learning scenarios. That's all. uh, Applications, okay, like computer vision and natural language processing. In general, I'll tell you some of the applications. So I have discussed only the first topic today. Any question? So you can also, find more material on internet related to this. But I think like the contents I deliver today are sufficient to understand what is transfer learning. Like examples were also sufficient to understand how exactly it can be used, right? You can also type your question in chat box. Okay, so if no question, then you can leave the meeting.